speaker from Oracle, and irritatingly, I've just realized I've changed the name on the slide, but not on the cover slide. So the cover slide tells you my details. I am the Oracle CTO for Capgemini in the UK, and I do that role part-time into North America. But I'm not joined by Andy Bond. Andy had a late triple booking, so I am joined instead by Christian Toms. I'll flick back to the agenda in a minute, but Christian, would you introduce yourself, please?
Yeah, sure. So I report directly to Andrew Bond. So I lead our specialist organization that interfaces between customers and partners and engineering, focused on data across the portfolio. So Oracle database plus our open source databases, and also including our database at and multi-cloud offerings.
Brilliant, thanks, Christian. And myself, I focus on business development, go-to-market, solutioning, etc. And I have been around the Oracle tech space for 25 years. I actually started life with Capgemini in 1999, did about 7 years, went away for a decade and came back. I think we're at a really exciting point in the Oracle story, right? And the Oracle story has changed a few times in the last, let's say, 6 to 8 years. It really has changed a few times. But the agenda today is to look at Oracle, what I've called Oracle Database Multicloud. I struggle with the multi-cloud thing, and you'll understand why as the agenda unfolds. But quick look at cloud adoption, customers' needs, the journey to address that, how Oracle has set about on the journey to address that, and then the key things that I wanted to present to you today, which are Oracle Database at Azure, at GCP, and at AWS. Why Oracle Database? What's the state of Oracle Database? Some insights into the latest version, 23 AI, and then a bit about the product roadmap for the database at Azure, GCP, AWS offers. What's the Capgemini offer? And what are we actually doing in this space? I think these stats probably don't surprise a lot of people, but cloud adoption is hard. For enterprise workloads, it's really hard. You know, if you're born in the cloud or if you're doing departmental cloud adoption, it's not so hard. But if you've got mission critical, by which I mean extremely demanding performance, resilience, availability, throughput, challenging security profiles, complex long-running business transactions, monolithic applications, etc. It's really hard to get those workloads out of the data center. Almost all enterprises, 98% of enterprises, according to S&P, Oracle, Goldman Sachs, are using multiple clouds. And yet, actually, of enterprise workloads, only 31% or thereabouts are in the cloud today. If you actually focus in on what I would call mission critical, so those things I touched upon about availability, resilience, throughput, security, even fewer of those are in the cloud today. And there are some reasons for that. And I'm going to ask Christian to jump in, and Christian, you'll have to shout when you want me to step through. But I think the first three of the things on this slide go to some of the customer needs that have impeded cloud adoption.
Yeah, I think that's fair. I think that the challenge for many of our enterprise customers has been that they've adopted Oracle, as you say, they've gone down a mission critical route. So they're following, for example, Oracle maximum availability patterns, and following Oracle maximum security architectures as well. And so moving to a hyperscaler that doesn't have some of the functionality that they've had before, like Exadata, which they've experienced on premises, or they've built their data centers so close that they can do a synchronous replication with DataGuard, has caused us a challenge. So the first pattern we tend to see is migrating Oracle databases and then modernizing and innovating in the cloud. And what I tend to see is customers are constantly wanting to get to a point of evergreening, and that they've found that as a challenge on premises. So there's a huge advantage of going to cloud on that point, but to get to that enterprise resilience has been a challenge. We then have the idea of migrating existing databases that have been a suboptimal Oracle experience for our customers in terms of ones that are self-managed within a virtual machine, for example. That's been a challenge as well. And then the other workload, which is one I spend a huge amount of time with customers, is building net new applications with Oracle database. But customers are wanting to surround that with their ecosystem, either in, I don't know, let's choose Azure for this example, where they want to use .NET, for example. They want to use a CI/CD pipeline with Azure. And yet Oracle sort of sticks out like a bit of a sore thumb, which makes taking some of the new features we'll touch on later on a slight challenge. We've also seen challenges, and I'm sure you've seen them as well, Chris, in terms of sovereignty as well as latency. So locality of region has been a challenge, as well as that sovereign nature. With Oracle's multi-cloud message, obviously we have a multi-cloud message that can come to the customer as well. And then we have the integration of data with our SaaS applications and data platforms as well. And the need to do that over low latency. And I've already touched on the multi-site challenge already. So really we'll focus on 1 to 3 going forward, but I'm going to touch on some of those other challenges as well, in the sense that we solve them with multi-cloud offerings from Oracle as we go along. Chris, do you want to go to the next slide? Because I think this will explain why you struggle with the multi-cloud world and why I struggle with the multi-cloud world. So I think it's worth looking at how we started this journey as Oracle. And we started it with a partnership with Microsoft. So the partnership started off with an interconnect, and we achieved that interconnect in 3 regions. Pretty much we focused on criticality of customer, but also location of regions. So we started off in the US with Ashburn, London and Toronto. We then moved on and extended that to Tokyo and Amsterdam, etc. And you guys can read the slides. So that was our journey through to 2022, and then we went and did something slightly different. So Chris, if you can, thank you. We then went to AWS and took MySQL HeatWave and ran it at AWS as a service in key areas. And this means that we're able to bring the MySQL HeatWave data platform to our customers in AWS, and we got great feedback from our customers that this was a way they wanted to work rather than having a pure interconnect approach, which then meant that we continued that journey. And if we hit enter again, or spacebar, or whichever tool will work with Chris, we then announced in 2024, much to some acclaim, the Oracle database at Azure service offering. Now, the Oracle database at Azure service offering wasn't the first thing we offered, actually. Over the interconnect, we tried to simplify in a cloud manner, and we had this thing called Oracle Database Services at Azure, which gave the Azure Cloud Control Plane interface and access to Oracle databases over the interconnect to inside OCI, and they were managed from an Azure control plane. What we found was that worked in certain use cases, but it wasn't what customers wanted. What customers actually wanted was they wanted a database service that was running inside Azure as a hyperscaler. And so that's what we're now delivering to them. So to Chris's point, it's slightly confusing in the fact that it's OCI managed. It's an OCI cloud delivery, but it's in an Azure region, delivered in an Azure region in a private cage, interconnected with Azure network over a very low latency physical connection. And we've delivered that in a number of regions, and we've got 24 more regions planned. And if we hit space again, hopefully this is the last part of the animation build, we then announced Google Cloud. And we're already deploying regions with Google Cloud, and we also introduced an interconnect as well. the interconnect is important because it gives customers choice. And then at Cloud World, we then announced a partnership with AWS to be able to deliver Oracle database at AWS as well. The Oracle database we'll talk about in a minute in terms of service, but Oracle database is a multitude of service offerings, from autonomous database, Exadata cloud service, as well as autonomous recovery service as well. So we can give a customer an enterprise experience. It's all managed from OCI, so we can control and deliver the SLOs that we do already and optimize the customer experience. But there's a full REST API integration plus the control plane directly into each of the hyperscalers implementations. I hope that covers.
Perfect. Yeah, I think it does. So if I pick the slides up again here, Oracle database. I'd be amazed if any of you are not familiar with Oracle database. 40 odd years heritage. But what I hear a lot is Oracle database is legacy, isn't it? Well, okay, one man's legacy is another man's heritage, but I think it's far from legacy. And we'll touch on some of the innovations in the subsequent slides. But Oracle Cloud Infrastructure, which is Oracle's hyperscale cloud in 50-ish commercial regions around the world, plus government regions, plus sovereign regions, plus what are known as isolated regions, plus dedicated regions and slightly other different variants, allows you to run Oracle database on top of Exadata, which is the system hardware, the engineered hardware that provides maximum availability, performance, throughput for Oracle database workloads and consolidation of Oracle workloads. You can run that Exadata as a cloud service. So instead of paying $1 million for a piece of hardware as a capital asset, feeding, watering, maintaining, patching, controlling it, writing it down over 4 years or 6 years as a capital asset, you can buy that as a cloud service spun up in OCI. You can spin it up and use it for as little as 48 hours and then tear it down and walk away. And you only pay for the period of time you're running it. If you want to do a license included model, so full PaaS model, license included, or if you already own database licenses, you can run the full PaaS model at a cheaper rate and use your existing license. But that is significantly different to buying £1 million worth of capital asset and writing it down. You can literally use it for 48 hours and then walk away. On top of that, you can also run Oracle Autonomous Database, and we'll touch more on what autonomous is, but there's a clue in the name. It does an awful lot of things itself without the intervention of an operational DBA. The latest version of Oracle Database is 23 AI, and this Exadata platform on which Autonomous runs is in, you can see the charts on the right, 8, 9, 10 of the top enterprises by size across various industry domains. So it's an extremely well adopted, mature, trusted, hyper-converged platform. So what's Oracle Database Service at Azure? It is physically Oracle Cloud Infrastructure built inside an Azure region. So as well as the external commercial, government, sovereign regions that Oracle has for its workloads, you have on the right-hand side of this picture, Oracle owned, maintained hardware built inside Azure data centers running Oracle Database Platform services on top, both the Exadata service and the Autonomous service. And of course, it's co-located with Azure Cloud Services, some of which are called out on the slide. So if you have, as Christian alluded to, say a .NET but Oracle Database centric strategy, or an existing investment and skills and tooling, etc., for Oracle Database, you can migrate those workloads, even that depend on RAC and Exadata, into Azure now and innovate alongside modernized transform application services using the adjacent Azure Cloud Services. There are some really critical things here. You consume this as a private offer, which is published in the Azure Marketplace. So you get a single bill via Microsoft Azure Services as ever, but you get a line item on that for your Oracle Database Services. If you have a Microsoft Azure consumption commitment, all consumption of Oracle Database Services counts as consumption against your MAC. Incidentally, the price of the services in here is the same as the price of the equivalent database platform service in any other OCI platform. So one of Oracle's differentiators is simplicity of pricing. Any Oracle service in any OCI region in the world is always the same single price. So you will pay the same per second of database Exadata consumption in a public cloud region in South Korea as you will do in a UK sovereign region or a US government region or an EMEA sovereign region or a database at Azure region. It's always the same price. It counts against your Mac consumption, but it also generates Oracle support rewards. This is where for every dollar of consumption on any OCI platform, you will receive 25 cents as a rebate, as a credit against any open Oracle technology support and maintenance invoice. So you can begin to offset your Oracle technology support and maintenance. You can use your existing licenses. So you spin these things up as platform services. If you don't have a license, you can spin it up as platform with license included. But if you have a license, for less than half of the price, you can spin it up, bringing your existing, using your existing entitlement. Of course, there's no intercloud traffic in a model like this. Although strictly speaking, there are two clouds, one within the other here. There's no charges for intercloud traffic. You can also modernize to autonomous database, which effectively obsoletes your operational DBAs. And we'll touch on autonomous a little bit more later in the presentation. So that is Oracle Database at Azure. Quite similarly, if I can click, yeah, this is Oracle Database at GCP. Kind of looks familiar, but you've got a bunch of GCP services. Again, you will get a single bill for Oracle Database and Google Cloud Services. Again, it runs on infrastructure physically inside the GCP region, but for which Oracle is responsible. Again, it's the same price as any other presentation of Oracle Cloud database services. It uses your Google committed use discounts, the corresponding commercial mechanism to Microsoft to Max. Again, it generates the support rewards. You can take your licenses. There's no traffic charges. You can modernize to autonomous database. Kind of familiar. You might know what's coming next. AWS, when it comes, so this picture is one that I knocked up for this presentation. But when it comes, it will be the same thing. Sorry, there's a deliberate typo on the slide where it still says Google, where it should say AWS. But under this model, you will use your AWS private pricing agreements. So consumption will count against your private pricing agreements. It'll generate the support rewards. You can innovate with SageMaker and EC2 and ECS and all of the other fantastic Amazon services, co-located with your Oracle database at AWS. So this is really a shift from Oracle that recognizes that, back in the day when some of us, like if you're long in the tooth enough as I am, you might remember racking and stacking hardware where I might have had a rack in front of me with a compute node on it running Oracle database and one above it running some Microsoft services. We're effectively replicating the same thing in the cloud. We're co-locating best of breed cloud services in a single place, eliminating latency, giving the customer a single set of pricing and a single sort of unified experience to modernize. Why Oracle Database though? Oracle Database is still the market leader. I mean, I often look at DB engines. Those of you that have not seen DB engines before, I suggest give it a look. They have their own mechanisms for ranking the popularity of databases based on things like hits on Stack Exchange, and Experts Exchange, and Stack Overflow, and things like that. Google searches, availability of resources, demand for resources in the market, etc. Oracle is still top of the shop and actually slightly growing. If you look at the light blue line at the top on the right-hand side of this slide, you can see that, yeah, Oracle has sort of slightly decreased maybe over the last few years, but then plateaued and is actually undergoing something of an uptick at the moment. And I suspect that's largely to do with all the excitement about this Oracle database at hyperscaler products. But there are things that really do differentiate Oracle. It is a converged multi-model database. We'll touch on that a little bit more. A lot of people think Oracle relational database. Yes, it is, but it's far more than that. Licenses are portable, unlike many first sort of cloud native databases from the other hyperscalers. The exact same Oracle database engine runs on-premise or in any of the other hyperscalers, whether as an hyperscaler model or on VMs, and you can run it in your own data center or OCI or anywhere else. It's always the same product, and the licenses are portable. There is over 40 years of accumulated innovation, operational tooling, security tooling, maturity around the product, plentiful Oracle resources in the market, and as we've seen it runs the world's mission critical workloads still. Christian, maybe you could dig a bit deeper into some of the innovations underneath the database at hyperscaler offers.
Yeah, sure. I think you touched on Exadata already, right? That it's one of the running options for Oracle database that our customers have already adopted heavily in the enterprise to consolidate or to run data warehouses on. Exadata is, I think, in its 15th year of heritage, which started off as a data warehousing appliance where we have it's a scale out technology with storage and compute separated. We now use an RDMA Rocky network to be able to make the storage intelligent. So the storage has always offloaded SQL as a smart scan, for example. It's done that for years. If you look at modern workloads, for example, where you're trying to do a semantic search with a vector database, that semantic search now can be offloaded to the storage cells, and it's running on AMD hardware, simple execution, and the storage will do the work. Now, I mentioned a Rocky Fabric already. The Rocky Fabric is used both for an interconnect of our VM clusters, for a low latency, high throughput connection. We run everything over 100 gig in this fabric, and obviously we can go point to point with RDMA for memory reads and writes across compute nodes as well as the storage cells. This XRM data accelerator is our way of being able to write directly to memory at an extremely low latency, which then means we can get high throughput transactions through. So traditional workloads such as payment engines or Internet of Things high ingest, we Exadata generally can handle those without a performance issue at all, and be able to then turn that into an analytical platform using columnar compression, for example, and presenting a columnar view of the data set for analytics immediately. We obviously have a sustainable answer to our customers, so we use the right resources in the right places, but more importantly, we'll apply technology such as compression to reduce the storage footprint of the ever-growing data needs of our customers. From a consolidation point of view, and we've got customers that are consolidating thousands of databases onto Exadata on their own, let alone where we're running it as a cloud service. You need to be able to do resource management in an intelligent manner. And so we've got software engineered within the platform that will do IO resource management, as well as network, as well as CPU and memory as well. We do traditionally take advantage of Smart Flash Cache, where I can do columnar compression on there, as well as handle persistent writes as well. And we're also able to offer, for example, our in-memory database with a fault-tolerant nature, so that a single node dying within an Exadata means the service still runs. There's no brownout, there's no repopulation of memory. Everything's there, all to work. I could go on. I think actually even on this slide, we're doing a subset of Exadata specific features for Oracle database, I think are reaching around 95 specific features for just Oracle in general before I look at specific data types as well. So I think that gives you an idea of the Exadata platform, and that's just the hardware which provided with software engineered on top to take advantage of that hardware, and it gives us a unique position. So we can control the service, we can set standards, we can set best practice. I used to work as a systems integrator. It removed all of the nature away from that complexity, and we can deploy in a standard per rack cluster in minutes in the cloud using that technology. Now, we introduced 23AI as the latest database to the succession of 19C in just after 23, actually. It got renamed as the AI database. So if you notice, we've always had, like, we were 19C before, the C was for cloud. This time it's AI, and it gives an indicator of where our development focus was. 23AI brings a multitude of features, all of them focused on generating, on being a platform to generate the next generation of AI-driven development and applications and analytics. Right down to the point that I can do declarative intent at the data model. So an LLM, when it's trying to build code against the Oracle database, can actually understand the data model and write the code correctly, which will reduce debug cycles or innovation cycles later on, right through to including new data types within our converged data model, for example, such as AI vector search. We also extended our JSON models that have been there since, I need to remember now, 12C, where JSON document types have always been available in the database. We've extended that, and we've introduced JSON duality, which allows us to have a relational model and representation of JSON documents and manage many JSON documents as one for data consistency, but enable you to develop actually against a fully compatible Mongo API within the Oracle database. One of the others we introduced with, or extended actually with 23AI, was we took our sharding database technology, extended that with the Raft algorithm. And so we now have a fully globally distributed database offering in the cloud that takes advantage of our autonomous database platform, but allows you to deliver shards and address use cases, for example, being able to meet the financial regulations in India for payment transactions to only reside in India, but for you to, your bank to have a global view as an option. We extended latency features in Oracle RAC, which is our real application cluster, which I describe as giving functionality that VMware offer for availability and management, but more importantly as a scale out technology as well for complete scale and growth. So you no longer require monolithic large vertical scaling hardware to meet your database requirements. I think I've touched on advanced compression. In-memory database is another important feature for us in terms of being able to provide low latency. With 23AI, we also extended that with True Cache, which gives you the ability to store all data types in memory as a caching layer alongside the back end of the database. The way to see it is it could compete with a Redis or an OCI caching service, or replace a ×10 implementation as well. Everything in 23AI also takes advantage of multi-tenant. 23AI insists on everything being multi-tenant. Even if you only run one pluggable database in a container database, you still deploy as a multi-tenant model. And this enables us to have a greater consolidation depth. It also enables customers to manage many as one. And it really does suit a microservice and cloud native development where you might want to have multiple services built with multiple different data models in isolation, but run that as a complete ERP application. Multi-tenant suits that as well. I think I'm going to stop talking for a little bit on 23AI. Chris, do you want to move on to autonomous, unless you'd like me to call out another topic?
No, I'm good. We'll click on to this one.
Thank you. So autonomous, Chris touched on before. So autonomous database is the same code base as Oracle Database 23AI. Let me be very clear on that. What autonomous does, though, is take the provisioning lifecycle, your configuration management, your security and not just encryption, but also your vaulting of data, for example, in terms of isolation and access, as well as being able to do automatic online patching and upgrades for you, as well as automatically scaling and shrinking resources based on demands, and tuning the database, all via automation. I'm going to say the word AI. Many of this is implemented in various different formats to enable the removal of human error as well as human labor. I think all of us are aware on this call that humans generally cause the most number of outages in IT and are probably the source of many security breaches in IT as well. So the less we have hands-on, the better. What this does is also eliminate downtime. We're very proud on this, actually. If you look on oracle.com under autonomous database, you can actually see our live service levels and the last time downtime occurred in any of the regions. And to give you an idea, last time I looked at the number of transactions autonomous databases completing in OCI, we were around 20 billion transactions an hour, to give you an idea of some of the performance that we're achieving. On the eliminating performance tuning, it's interesting. One of the things autonomous can do for you is evaluate indexes, and you can choose whether you want this to happen, but it'll auto tune your indexes. We actually use autonomous under our NetSuite application. When we introduced NetSuite to autonomous, we asked it to auto tune, and obviously we've done a lot of testing, but it took the magnitude of indexes down by a factor of 5. And when you're talking number of indexes that are in their thousands, reducing that level of complexity whilst increasing performance by reducing those number of indexes, we were amazed. And people have been trying to tune those databases for years. So I think autonomous has a real advantage to you. The significant one for your customers, though, is that auto scaling. It only consumes the resources that are required. You can control that scaling. It's the maximum you can set it to is a maximum of 3. You can consolidate a number of databases to be considered together to scale up and down if you want to, but it auto shrinks the database service as well. And I see this as unique. I don't see any other customers doing this in real time or any other providers doing this in real time. And it can dramatically reduce your cost of running an Oracle workload in an enterprise cloud.
Thank you. Thanks, Christian.
I think that covers a large amount.
Yeah, I think it does. So I guess it's one thing for Christian from Oracle to tell us that autonomous database is a game changer, but there is some really good weight of evidence now in the marketplace, because autonomous is several years old now. Adoption has grown quite rapidly. It has moved from being something that was really applicable to departmental workloads into more and more into enterprise workloads. I don't think Oracle E-Business Suite is yet certified for it, but I think I'm right in saying that PeopleSoft is. And I think there are plans to certify E-Business Suite as well. I'm aware that there is a team that's running inside Oracle now to help drive more enterprise features into autonomous database. So things like key management, for example, that some enterprise customers want that autonomous was not previously able to do are being rolled into the product. So there is a big push to get more and more workloads into autonomous. But I had a dig about on Gartner. You can actually download this. I should have put a link, but if you Google it, you'll find it. You can actually download this report for free from Oracle's site as well. They looked at cloud database services at the start. This is from January 2024. An autonomous database came out on top in every use case, significantly on top in every use case. We talked about Oracle database being multi-model. It is not just a relational database. We've seen it's been the trusted choice for a lot of, something like 90+%, 93% or 94% of Fortune 100 companies already using it. But with 23 AI, Oracle's built on that further, putting AI vector search into the database, along with 300 other new features and enhancements. So As well as relational database, Oracle is a graph database. It's spatial, it's JSON and document. For several years, it's had blockchain tables in the database today. So it is not just a relational database. It is converged multi-model database. Sorry, I think I'm out of the view that I was currently in. What AI vector search allows you to do is embed vectors, take your structured or semi-structured and unstructured information and run a vector embedding model to represent that data as vectors and do vector search, vector comparison, vector indexing within the database. So you can generate vectors natively, store them, and query over the top of them as well in the same query as querying against traditional relational or JSON data in the same database model. So it builds the ability to do Gen AI and vector search, etc., and develop AI-driven modern applications within a single database model. Again, it's one of the differentiators that Oracle has compared to single-purpose database models, this converged multi-model paradigm. AI vector search essentially is there to support using LLMs. So you can run an LLM, augment it with your private business data or domain knowledge, store the vectors as a native data type within the database, and make it really simple and fast to search both structured and unstructured data and combine those results with results from traditional database queries. So source data of virtually any type and the vectors representing it, stored in the same database. You don't need to build integrations between different database models, so it reduces IT complexity, reduces the challenge of operating, securing, managing, maintaining, particularly in the autonomous model. An AI vector search combined with RAG, retrieval augmented generation techniques, helps provide LLM users with more and more accurate responses to reduce hallucinations. One of the key things that you can do is not only generate vectors from your data in the database using seeded embedding models, but you can bring the model to the data as well. So if you have a third-party model, you can import that into an Oracle database using the Onyx format and use it to generate vector embeddings inside the database. So rather than taking data to a model, you are driving it the other way around, bringing the model to the data. One of the other innovations in 23 AI that I wanted to call out, apologies, my view keeps changing on the screen here, is globally distributed database that Christian touched on. So this breaks a single database into a distributed set of shards, and these can be in any Oracle database. So this doesn't have to be Oracle database in the cloud. This could be in a public cloud, public OCI region. It could be in an OCI at hyperscaler region. Another shard could be in an Exadata cloud at customer solution. So that's inside your own data center, what looks like a traditional piece of Exadata hardware, but actually has a cloud control plane on it. It's interoperable with all the cloud, uses the same cloud SDKs, cloud APIs, the same control plane that you have for an Exadata cloud service, but the hardware physically sits in your data center and the data never crosses the customer firewall. So you can have a shard that is inside a data center, another shard that's in another geography, another shard that's in another geography, and operate them as a single logical sharded database. I think Christian touched on Raft replication as well, which is new for 23 AI. The colors on this slide are a little confusing. The colors are different between the top and bottom pictures though. So effectively in raft replication, you have one shard, which is the leader and distributes to the others, and then a second chunk of data, which has its leader in a different shard and replicates to the other two. There's no data guard or golden gate underneath this. This is all part of the 23 AI database engine itself, and uses the raft protocol to achieve consensus between shards. I think the two more features that I wanted to call out. One is even further increased security in the Oracle database, which already has a raft of security features. But a new thing in 23 AI is known as Oracle SQL Firewall. So this is effectively, it's machine learning driven again. It learns the pattern of SQL queries incoming from applications and will recognize when it sees a pattern of behavior that is unfamiliar, and can either block or log that behavior. So it has a permissive mode where it just logs the requests, and an enforcing mode where it will actually block patterns of SQL queries it hasn't seen before. So if, for example, somebody did manage to somehow bypass security protocols that ought to be in place and was trying to do direct select statements to get, for example, PII data, it would recognize that that's an unusual query and would block that query. And this isn't an additional piece of software you have to install or that you have to configure. It's there by default out of the box with the database. It's simply included in the product. And then I think the last thing I was going to mention was graph database. So what are property graphs? They are ways of representing data that would hitherto have been really, really difficult to represent through SQL joins and joining multiple tables together, that allow you to do things like detecting communities, finding patterns in data, finding influences in groups of entities, identifying structures and paths between different entities. So graphs represented as nodes and edges. Property graphs allow you to walk these paths between nodes, so you can do what's known as a deep walk, following paths from one node to another to identify relationships between nodes. For example, is one bank account related to another bank account? Is it related to it by multiple paths, for example, for detection of fraudulent patterns of behavior? It's also excellent for recommender systems. Is a particular consumer who's interested in one thing likely to be interested in another thing? How to identify similarities in consumers who may have similar interests and be interested in similar recommendations. So you can use these things for fraud detection and product recommendation, to identify dependencies, or for network analysis. There's lots of examples of use cases of property graphs. There's a new SQL standard which Oracle has implemented or introduced under SQL PGQ in 23 AI, that allows you to very simply declare a property graph table and then run SQL select statements over that property graph table, rather than prohibitive multiple joins between different tables. So it allows you to create a representation of relational data as a property graph and then query that property graph in really simple syntax. They're just 4 of the innovations. I'm sure that Christian could talk about more. He mentioned JSON duality to me earlier on. There are many innovations. Christian, maybe if you just we could go back to the hyperscaler product of Oracle database. We've looked at 23 AI, some of the innovations, but where and when can I get it in the different hyperscalers?
Yeah, it's a good question. So I think what I'm going to say is at the start, and I struggle to remember all of the regions all the time. So please apologize or accept my apology for not remembering all the regions and use the slides at the start. What we have here is what services are currently available in the hyperscalers at those regions. there is a region rollout plan, and we're happy to hear of demand and help that focus us and our partners as we roll out as well. So I'll let you read the slide for where as the regions come. For Azure and Google, we offer the autonomous database serverless variant. And that enables us to do serverless compute, so a complete shared model where we can do both ATP as well as ADW workloads, so transactional data warehouse. And after popular demand, Azure, we're also going to bring autonomous JSON, which is basically the autonomous transaction processing database, but with a lower entry point for smaller JSON type workloads, as well as the Apex service that also is available in ATP today as dedicated services. In Google Cloud, we've already deployed those in the regions available. Both of them have a pay-as-you-go variant as well as the private offer variant for autonomous as well. Now, what you'll notice is that we've then got this line item, which is autonomous dedicated. In autonomous inside OTCI, we have two variants. One's serverless, one's dedicated. Dedicated is where you've taken the Exadata Cloud hardware subscription, which is dedicated infrastructure to yourself. And then we allow you to run autonomous dedicated services on top of that hardware. The contract to AWS is that we will go down that route. That variant also, Chris, just for your information, means that we still have it as a limited access trial, but we're currently doing an LA program for eBusiness Suite with autonomous dedicated in OCI, and obviously it would be available when the regions are deployed at AWS as well.
Gotcha. Thank you.
Exadata database set. Go on, Chris.
Sorry. No, sorry. I'm just conscious of time. I was going to move us on to regions, but
yeah, no, that's fine.
Sorry.
I can, no, you're fine. Exadata database cloud services everywhere because it underpins everything. And then the recovery service, which has immutability as well as data protection for every transaction available to you, is also planned at Azure and Google. The rest is for the reader. So everything that's planned is planned. There's no committed dates at this time.
Thank you.
Go on, Chris, moving on.
I was just going to quickly show regional availability where this is today.
Perfect, thank you. I knew I couldn't do it from memory, but a slide helps. So in France, we've got Microsoft Azure regions and obviously OCI. Germany, both is Google Cloud and Azure. Italy, Azure and OCI, and there is a planned deployment for Google. We've also got planned for Azure in Sweden. We are already live in the UK for Google and Azure. And we're also planned in the Middle East on Azure. There's no preference to any of our partners. It's literally we started earlier and they've been able to help us get infrastructure in and get that connectivity out. We will continue to grow this. We don't intend to slow down at all. And I know AWS is keen. We'll start in North America, and then I'm expecting it to come to EMEA over the next. I'm gonna say 12 months as a guess, but don't hold me to that, please.
Thank you. So just a couple of slides left. How do you engage if you think you have an opportunity here? So firstly, think about the profile of your customers with an Oracle DB estate, especially RAC or Exadata, with an Azure or GCP or AWS in the future strategy, customers with a Microsoft Azure consumption commitment or a Google committed use discount. They may have multiple requirements. It might be as simple as a DC exit requirement, lift shift to the cloud. It may be an app modernization program that this gives an opportunity to get out to the cloud as they modernize. Could be analytics and AI driven. It may be a reduction of portfolio risk, so multi-cloud in order to mitigate geographical risk. Or it could be pure and simple IT cost reduction. We've seen this ability to use your committed use discounts and MAC and generate Oracle support rewards as well. So think about the profile of customer. engage the customer in a conversation, or reach out to myself and we can connect you to the right person in your region, or lean in and help with that conversation. And then if the customer is interested in something like a 2 to 6 week period, there's a number of things we can do. Oracle provides something called the Estate Explorer. We can ingest a CMDB detail, or actually execute Estate Explorer on an estate to get a really good view of the potential business case, the proportion of the database estate that might be able to transform to autonomous, and get an insight into the business case. From that, we could move on and run what's called the Cloud Pre-Migration Advisor tool. This runs a further set of tests, 90 odd, I think, tests that give you an indication of how difficult or easy it is to transform the databases to cloud. We can do some estate sizing and help with business case. And then after that, anywhere from 3 to 12 months on the migration piece itself, we have reusable strategies and architectures and some automation and scripts, as you'd expect. And Oracle provides tools to assist with the migration, a tool called Zero Downtime Migration Service, plus a managed database migration service. And there are other tools like the Enterprise Manager Migration Workbench. There are a couple of slides in here. I'll send the deck out, but I don't want to talk right to the end. I want to leave a moment for Q&A. So there are some slides that show high-level patterns for database Azure exploitation. There's a couple of slides with them consolidated. And then at the end of the deck, there are individual slides with more detail. But I want to call out where we're doing this. We're doing this in 2 engagements already in Capgemini. One for BASF in Germany, 620 databases. Roughly half of those, more than half actually, 60% are expected to, the numbers are at the bottom, 254 actually of the 347 we've analysed will likely transition to autonomous. So we've not analysed the whole estate yet, but starting in the German data centres, of the sort of 350-ish, five out of every 7 could potentially transform to autonomous. The rest will go to Exadata. And the Nespresso engagement is a little bit earlier on. This is from existing Exadata estate of about 250 Oracle DBs. So we've covered a lot of content. There's just a few minutes left. If anybody has questions, happy to take questions, and also happy to take questions offline, and I will share the deck afterwards.
Yeah, thanks a lot. There was one question in the chat already, which is there support also base database services to the hyperscaler Azure, GCP, and AWS from David?
So, Christian, you might know quicker than me, but I think base database is on the roadmap. Yes, so it is planned, isn't it, for Azure and GCP?
I think. I think we'll be able to give you a base functionality using either the Exadata Cloud Service or autonomous is the first thing I'm going to tell you. The other one is we have to remember that we partner with these hyperscalers who already offer Oracle database in a VM, which is the base service. So I think the customer already has options to migrate if you're looking at base only, as well as a roadmap of the future as well.
Good point. Are there any other questions? Okay. Adrian, thank you.
So Chris, I've just got one just to add. When you covered Oracle Firewall, one of the things that our customers have asked, and actually in some of the learnings of multi-cloud deployments already, is how do we manage many as one? And one of the things I didn't mention is that with all of our services, Oracle Data Safe that allows you to do security governance of the Oracle database, allows you to manage that SQL firewall as many as one, as well as to give you security insights. All of that is included with every single one of our database cloud services, no matter where it's consumed. Just another little point just to add in there. I know security is a key topic for every one of our customers.
Yeah, indeed. Okay, thank you.
Great, thanks a lot.
Thank you, Adrian.
Any further question after the call? Don't hesitate to reach out to Chris directly.
Thank you. Thanks a lot for inviting us, and thank you, Christian, for joining.
Chris, thank you for asking along.
Thanks a lot. Bye bye.
Thank you. Bye.